So Bobby,
Yes.
we discussed negative clamper yesterday.
Negative clamper.
Yes, maybe
we
we'll quickly
have
draw
shifted
it.
down.
We have shifted it down, right? So maybe we'll quickly draw it.
Yeah. Yeah.
So let me see. So I think we did. We took a sinusoidal voltage source, Vm sin omega t.
Then we had a capacitor and a diode.
Sin omega t, and I think we had a capacitor and a diode like this. Is
Yes.
this correct? We did it the other way.
I think
the other way. Okay. Okay. So I think this is the circuit that we had yesterday.
Yeah.
Correct. That is correct.
Correct.
This is the circuit that we had yesterday.
Yeah. And we looked at the voltage across the diode.
We looked at the voltage across the diode. So if I'll just draw the representative diagrams.
Yeah.
If this voltage is like this, sinusoidal voltage, what you will get across the diode is the, I just, again, there is no time domain response, but I will just show that maybe just representative is, I'll get something like this.
Yeah.
Something like this, right?
After,
so this is 0.
After some parts
After
of the
some
cycles.
time, after some cycles,
Yes.
right?
Yes.
But
Yes.
representative diagram.
Yes.
So it will go from minus 2 Vm to 0.
Yeah.
And it will be kind of around minus Vm. Whereas the original one was around 0 and it will go from plus Vm to minus Vm.
So now there is an average value of minus Vm.
Average value of minus Vm. And maybe we should also look at how to get an average value of plus Vm.
So shift in the positive direction.
Shift in the positive direction, right?
So basically now capacitor will have to be charged in the opposite direction.
Capacitor will have to be charged in the opposite direction, correct. So how do you propose we do it?
That means in the negative cycle, the capacitor has to charge.
Correct. So which means
Flip the diode.
Flip the diode, right? Okay, let's try that, see what it gives. So I'll show the circuit here and then we'll redraw the circuit and the full diagram on the next page. Like this.
Yeah.
Right?
Yeah.
Okay. So let us see.
We hope.
We hope, exactly. So that is why we'll look at the circuit here.
Yeah.
So this was the negative clamper, no?
Yeah.
Clamper circuit.
Yeah.
That is what it is called. We hope that by shifting it, it will give the positive clamper. Let us see. On the positive side, it looks like the diode is reverse biased.
Yeah.
Right. So we'll ignore that for now. We will plot the actual curve
Correct.
later. On the negative side, the diode is forward biased. And
so the capacitor will charge
the
to
peak value, which is minus Vm.
Yes.
Right? Like this. So it conducts like this. So it will charge to
exactly
minus. It will charge to Vm like
correct.
this.
Correct.
Okay. And then after that, the next one.
Yeah. So actually, we can think that way also. If I have a sinusoid source and then if I add a battery
Add
to
a battery to it. Correct.
You have shifted it by.
I have shifted it by.
So the battery is now capacitor.
Correct.
Yeah.
In fact, that's a very good way to look at it.
Correct.
Let us just draw it on the next page.
Yeah.
So I'll take this one. Right. So let us see. This is Vm sin omega t.
Yeah.
No, the diode direction we changed, no?
Yeah.
Correct.
Correct.
So let us say we start at t equal to 0. So this is, we called it V naught.
Yeah.
Okay. Now I'll draw the input voltage in black and the other one in color. Something like this.
Yeah. Yeah.
This is my input.
Yeah.
So this is Vm sin omega t.
Yeah.
And
or we'll choose a red color.
Red color. Okay.
So then it will be.
It will be bright.
Yeah.
Right. Okay. So now at t equal to 0.
Yeah.
We said for the positive half cycle, the diode is reverse biased.
Correct.
So the capacitor is initially charged to 0. We'll assume that. So if the diode is reverse biased, no current can flow
Correct.
through the capacitor.
Correct.
So the capacitor cannot get charged or discharged.
Yes.
It will still have 0.
Yeah.
So then it looks like it will follow the input, no?
Yes.
When it is positive.
Correct.
Correct? Okay.
Because
And
diode is reverse biased, there is no current flow.
there is no current flow. There is no current flow. Capacitor cannot charge or discharge.
Yes.
Right?
Yes. Yes.
So I is C dV by dt.
Yeah.
I is equal to 0.
Correct.
dV by dt is equal to 0.
Correct.
Voltage is constant.
Correct.
Right? Okay. Which was 0.
Yeah.
Okay. So then
Positive cycle is over.
positive cycle is over.
And
Then
the negative cycle comes,
negative cycle comes,
diode turns
diode
on.
will turn on.
Yeah.
Right?
Yeah.
And students can see with their usual trick, no?
Hmm.
I like your trick. So you open the diode
Yeah.
and see what the voltage is.
Correct.
Clearly here the bottom side is positive and the upper end is negative.
Negative.
Because the capacitor voltage has not changed.
Correct.
Right? Then if it is forward biased, the voltage is 0, no?
Voltage is 0.
Okay. So for that full cycle the voltage is 0.
Will it be for full cycle?
Good question.
Because now capacitor starts charging.
Capacitor starts charging.
Hmm.
How much does it charge? Oh, it can charge to the peak.
Correct.
Perfect.
Correct.
Okay, so it cannot go full cycle.
Yeah.
It will go on till the capacitor hits the peak.
Yes.
When does the okay, the capacitor hits the peak here.
Yes.
Huh?
Yes.
So Vc is Vm, no?
Yeah.
At this point.
Hmm.
This is 3t by 4,
Yeah.
right?
Hmm.
So this is t. Oh, excellent. Okay, I
We
like
will
this.
mark that capacitor
Capacitor voltage.
direction
So it is
also.
charging like this, no?
Yes.
So it will be like this.
Yeah.
It will charge to plus Vm.
Correct.
And after that it can't discharge.
Yeah.
Even though the input voltage is reducing,
Yeah.
the diode will be reverse biased, so it can't discharge.
Correct.
Okay.
Because diode bottom side you have some voltage less than Vm.
Correct.
Top side or cathode side we have Vm.
We have Vm. Correct.
So diode will be reverse biased.
Diode will be reverse biased. I like that. So till here,
Yeah.
till 3t by 4, it is short. Diode
Correct.
is forward biased.
Correct.
Okay. So after the capacitor, it cannot discharge, so diode remains reverse biased or starts to get reverse biased.
Yes.
Okay. Which means the voltage across it will be so it will be the input voltage plus Vm,
Yeah.
right?
Yeah.
Okay, so the input voltage was minus Vm,
Correct.
so it will be 0,
Yeah.
and after that it will be the sinusoid,
Exactly.
right?
Yeah.
So at this point this was Vm, no, earlier?
True.
This one will go to 2 Vm,
Yeah.
and at this point it was minus Vm, it will go to 0,
Yeah.
correct?
Yeah.
So if we just do something like that.
Yes. Exactly.
Oh, perfect. So,
Exactly.
and this is Vm, no? So
Yeah.
it will become almost like you said, no, right at the beginning. We see that it is getting charged to Vm.
Yeah.
So you just take the KVL will tell us that
Correct.
after that,
Correct.
so that as long as the diode doesn't get forward biased,
Yeah.
the voltage will always be Vm plus Vm sin omega.
Correct.
Perfect. Perfect. So this is that voltage. Perfect. So this is your positive clamper.
Yes.
Oh, nice.
Now, in case I connect a load across the diode,
Okay.
then some discharge of Vm, capacitor will happen.
Correct. That is true. That is true.
So that means whenever it comes to 0, or it may come to 0 before that point.
That is true. It may come to 0. So the curve will shift slightly, no?
Yeah.
Okay.
And the charging happened in the T by 2 to 3T by 4. Like that, in every cycle, there may be a small charging period.
That is true. Correct. I agree. So I see what you're saying.
Yeah.
So if you have some small resistor RL
Yeah.
or large resistor RL,
Correct, correct.
then the capacitor, so I know. So if I were to draw the capacitor voltage, so the capacitor voltage was 0 till this point, till T by 2,
Yeah.
right?
Yeah.
It was 0. So 1 minute. So let me like this. So the capacitor voltage was 0 till then. Then it follows till 3T by 4 and then stays constant originally is what we
Correct,
thought.
correct, correct.
But now that you have RL,
There will be a
it will
discharge.
be a small discharge. If
Yeah.
RL is large,
Yeah.
in kilo ohms or mega ohms or something, this discharge will be very slow.
Correct.
Correct? So I understand. So you'll need to make up for that
Yeah.
in the next cycle.
Yeah.
Perfect.
So that we will leave it to the students to think.
To think about it. Perfect. I see what you're saying.